This is the interpretation of the independent samples t-test, and here you can see the output. I would save that, make sure that you have the output saved somewhere that you can access it. So I'm going to say ACT output and save. But I actually went ahead and in the last video, I showed you to export it to Word, and I'm going to open it in Google Docs. So again, you get, I have my correlations in here. Let me clear that out. There we go. Okay, so it's going to look like this when you download it. So you need to get rid of this extra information. This isn't useful, and it just makes it harder to view this. So I'm going to delete this. And if you highlight all of it, you can delete it. It's a table, so you might need to right click and remove table. This is going to look a little bit messier because it's in the output, it's really long. So see how this is really long horizontally, it's really long. So it gets cut in half, it gets kind of chopped. So there's some important parts about the t-test that you want to be comfortable with. So I'm going to put a note here. This is our independent samples t-test. First, group statistics. So this is our first information table. I'm going to add a note here that I have two conditions, right? So I have this is my ACT practice score after the program. So this is the mean of ACT. So I'm going to say ACT for the control condition, which is our regular program, had a lower score, lower mean. And then I'm going to put this in APA style. So I would say that it has a lower mean, and then I would put the mean equals 23.19. And I'm getting that number from here. So this is our control condition line, and this is all about the ACT. So I'm going to highlight this. So this is the control condition that we're talking about here, which is the regular program. So I'm saying the mean is 23.19 and the standard deviation is 4.94. So I want to round up or down as appropriate. So if it was 5, I would say 0.95, I would round up, but this is less than 5, this 3, so I'm going to round down. So you should only have 2 numbers after the decimal. Let me make this a little bit bigger. Okay, so now had a lower mean than the experimental condition, which is our new intervention. And for this, and I'm just putting, this is just as a note for you. This isn't something you would actually write out. We'll practice in APA style. This is the new intervention. I'll just call it new intervention. Experimental new intervention. And then you would again put the mean of that group. So the mean of our experimental condition for the ACT, and we'll use that. So the mean equals 29.61. It's this number here. And our standard deviation equals 2.52. So by writing this out under here, this means that you have easy access to it. You're going to have to include this in APA style in your paper. And I'm gonna even do the italics here. So this is supposed to be italicized. If you remember from method section discussion, you'll italicize the mean and standard deviation. So this is just describing in the sample. And you could even put in the sample to remind yourself this is just that we're just describing it. This is just descriptive at this point. So now the independent samples t-test. The trick with this is that the first thing you need to look at is Levene's test for equality of variances. So for the Levene's test, what it's looking at is basically this section right here, which I will put in, let's put turquoise. Oops. I'm going to say that Levene's tells us if we can treat the groups as equal. So if we used random assignment to groups, then we make that assumption, right, that the groups are going to be evenly distributed with their individual differences. So the Levene's test actually looks at that. So it tells us if we can treat the groups as equal. So the key here is that we can assume equal variances if this value right here, this sig, if sig in turquoise is greater than, I'll just say not less than 0.05. So that's this one right here. So equal variances not assumed if sig in turquoise is less than 0.05. So there's more detail on this in the guide for you. So here, what our decision is that we cannot assume they are equal, that their variance is equal, because our significance equals 0.013, and that is less than 0.05. So if this happens for your group, what you need to do is that just means you're going to look at the bottom level. If you have equal variances assumed, then you get to stay on the top here. But this is the situation. So we only want to look at this lower level. So I'm gonna change the font to indicate that that's the information that we need to look at. So I'm gonna make this a dark red here. So this is our line, and that's going to continue here. We need to use the equal variances not assumed. So I'm just going to highlight that. And I'm going to use, again, my equal variances not assumed for this line. And I'm going to use it for this line. So you're going to use it for everywhere it says equal variances not assumed. Okay. So we need some information from this test. You can put it above, you can put it after each line, whatever works best for you. Here, we can see that our t-score, this is our t right here. Our t-score is, t-score equals negative 4.68. So that is our t-score, 4.68, negative 4.68. So that is some information that we need, that we will be reporting. So you could, again, put that somewhere else. I rounded down because that number is a 4. If it were a 5, I would have rounded up, but you want 2 points after the decimal. So now we have a t-score. We also need our degrees of freedom, which normally we would just do our total minus 2, but because we're using this correction for equal variances not assumed, we're going to report this 21.73. So you're going to highlight that, and I'm just going to put a note here that our degrees of freedom equals 21.73. And I have my p-value. So this was a one-sided test. So I'm going to use this one-sided significance. This is our p-value. What I want to point out here, let me make this a different color. That doesn't work. Let's do that. Okay. What I want to point out here is that they're the same because it's so small. So we're going to say that our p is less than 0.001. And you're going to actually italicize your P and your T when you write this out in APA style. So you could go ahead and italicize them now. We have a mean difference here. You don't need that. It's the difference between the groups, the standard error difference. You're not going to report that. We are going to talk about confidence intervals. So confidence interval is the idea of a range around, it's an interval around your t-score that you found. And you basically, the idea is that you would say that 95 out of 100, if you use a 95% confidence interval, 95 out of 100 or 95% of samples would be between these values. And if it crosses 0 for a t-score, then it's not significant. But we'll talk about this more in lecture, and you don't have to write about confidence interval in your paper. So for this, I'm just going to add a note here that my confidence interval, so I have a lower confidence interval equals this one. So see lower right here. So my lower confidence interval is negative 9.27. And this is narrow. And then our t-score falls in the middle here. So I'm going to put the t-score, which was negative 4.68. Oops. Negative 4.68. And then we have our upper confidence interval level, which is right here. And you can see that that is negative, equals negative 3.73. So we think that 95 times out of 100, we would get a t-score that ranged between negative 3.73 and negative 9.27. So that is how you get that information on the significance. Now for the independent samples t-test, you have a different effect size. So this is where we do Cohen's d. Cohen's d is the appropriate effect size that we're going to use. And you can see here that we have Cohen's d effect size. And what I want to use is this point estimate. So I'm going to use that number. The hedges, let's try highlighting. There we go. The hedges correction you would use if you have less than 20 responses, but none of you should have less than 20 responses. So that shouldn't be an issue. So this is our Cohen's d. So our Cohen's d equals negative 1.67. And again, I'm going to round up. So I only want 2 after the decimal. And I want to note here that is a large effect size. So that is how you would go through and use the information to interpret what's happening in your data. And then you'll spend time working on this in lab and lecture.